Hey, everybody. How about this, huh? How's this audio here? I hope everything is sounding okay early on. I'm gonna go through my usual ditty here and get everything set up now that I'm live. So I can click on that and I should be able to reload this. And I'm gonna check on the audio. Hold on a sec. How's that? Does that sound pretty good? Pretty good? Pretty good? I think that sounds all right. Warnock 69XXX. How's life in the fast lane, man? I wouldn't know. How's that sound, Warnock? Does that sound relatively decent? Too loud? Too soft? A little better? A little improvement? Pop out the chat here. We like it when things are a little better, at least. The only uh, the only real problem is I've got to hold this dumb thing. I don't have a mic stand. Just way too much of a cheapskate. I mean, I'm a musician and I don't have a mic stand. Stupid as that. All right, I'm gonna get going on this. Let me uh, let me see if I can do this single-handed here. I just got. Okay, I'm going to take my headphones out so I don't hear myself. All right, that's much better. Much better. All right, well, so welcome to Astronomy Daily Live. Just getting set up here, so hang tight for a minute or so, a couple of seconds while I get everything going. Uh, I'm gonna do that, and yeah, it's called. Yeah, we'll do that. We'll do that. And this, I'm probably. Let me move these screens up. Let me move the chat down here. Let's see if I can do that. Can I do that? I should be able to do that. Yeah, there's the chat. Hey. Glad you could pop in. So yeah, this is Astronomy Daily Live. This is a daily show where a circle of friends comes together and we talk astronomy for an hour or so, something like that. So this happens every single day at 2 hours UTC, and you're going to have to figure out what time that is depending on where you are on the planet. Um, I'm located in southeastern Arizona, United States, and I'm always on Mountain Standard Time, which is 7 hours behind Universal Time (UTC). That's Universal Coordinated Time or Coordinated Universal Time, which somehow translates to UTC. It's probably a language thing of some sort over in Europe where UTC. Yeah, I don't actually know how that happens, but I'm 7 hours behind UTC. So if it's 2 hours UTC uh, in Greenwich, England, which is where uh, this is sort of based, and I'm 7 hours behind that, and that puts me at about 7 p.m. local time. So right now it's about 7:05 p.m. Local time. So for those of you who are watching live and those of you who are watching in the future, welcome to the circle. Glad you could come by. Looks like everything's okay. I hopefully have made a slight upgrade to the audio. It still isn't quite as nice as I want. Maybe there's a little bit of noise in the background. What I'm going to do really, really quick here is check to make sure that the settings that I made a little while ago for the mic are still set to what I am hoping that they are. So go there, go to properties, go to levels. Yeah. So it looks like everything is still set to what I thought it was. I did an audio check right at the beginning of the show, and it sounds okay. It sounds all right. Play with the focus a little bit. See if that's okay. It looks all right. Yeah, it looks okay. I'm watching the live stream over on my smartphone, and then I have the chat up on my Linux machine, and then I have this camera on a laptop that's running Chrome, because apparently Chrome is at least one of the browsers that you can do these live streams from. Doesn't work with Firefox apparently, so that sort of sucks. But that's how it goes. We have to go with the flow. Go with the flow. So Astronomy Daily Live is just a very casual, um, open-minded, skeptical, hopefully fun discussion about astronomy. We we can dive really, really deep, or we can stay really, really easy. So this is for newbies, just getting into this maybe as a hobby. Um, this show is for amateurs, it's for advanced amateurs, and it's for pros. So everyone is welcome. If you'd like to be on the panel, you can you know put yourself in a little box down here on the bottom. I guess it'd be over. It usually starts over here and goes over. Um, that would be very, very cool. And you can email me at cosmiclettuce@gmail.com. And when the show goes live, I can send you a link and put you on the panel, and then we'll not only have the chat going, but we'll have panelists as well. And then this can even be more interactive, because I'm not intending for this show, to be just me blathering on for an hour. I'm more than happy to do that. There's more than enough astronomical topics to cover, so I'm more than happy to chat here uh, and just have you listen along and participate in the chat. But definitely, if you want to be a panelist, come on in. That might be interesting. Haven't had a panelist yet, so would definitely like to get some folks on board with that. So tonight, I guess let me cover a little bit more of the intro to Astronomy Daily Live. So, as I said, this is for everyone. Everyone is welcome here. I definitely want to keep the topic towards astronomy, but we're going to talk about science and the scientific process and uh, those kinds of things. Um, but well, and the conversations I would definitely like to be directed by this circle of friends that are gathering here. Um, but if there aren't really any topics in the circle that anybody wants to cover, as I said, I've I've got um, a bunch of them in my back pocket, and I will certainly pull those out when the need arises. So this can be like a Q&A, and that can be both ways, right? I can certainly be asking you things as well. I definitely do not claim um, to know even even a little bit. Um, I know a few things. I've been doing astronomy my entire life at every single level, so Q&A is certainly appropriate. But we can talk about observing, we can talk about gear, we can talk about telescopes, we can talk about instrumentation like cameras or spectrometers or photometers. We can talk about analyzing astronomical data, and I'm gonna be showing you a little bit of data that I just collected a few minutes ago, about half an hour ago here, um, pretty soon. All kinds of research. What do astronomers do? What's sort of their daily routine? Um, Definitely want to talk about any interesting journal papers, scientific papers or otherwise that may that may pop up. Let's talk about personalities within the astronomical world. A lot of people involved, and there's a lot of interesting people involved. So let's talk about them. Definitely want to start including some astro art in this conversation for sure. Let's talk about the different astronomical projects that are either going on now, have occurred in the past, or will occur in the future. Um, Pretty much anything else up for grabs. As I said, this is a skeptical yet open-minded conversation. So I'm gonna dig hard into things if we want to, and but we'll definitely keep an open mind about any topics. Science is a process. It doesn't have a beginning and a middle and an end, and then it's over with. It's actually what's called a process fractal. So the inputs sort of feedback, or I'm sorry, the outputs sort of feedback into the inputs, and it just goes around and around and around, and it's a cycle like that. So no one ever has the answers. Anybody who claims to have, the answers about things is, deluding themselves. And actually, to put scientists up sort of on the pedestal as being sort of the high priests with the answers, yeah, that I think puts a lot of pressure on scientists, um, to be in a position like that, and I don't think that's exactly fair. Science is a process of inquiring about things, and following your curiosity, and see where it goes, and making guesses, and comparing those guesses to observations, and there are a lot of possible ways that these guesses can go, and there may be many guesses that sort of match the observations really really well. So who knows? Who knows? Um, so yeah, consider this sort of a daily gathering of friends um, in a circle, as if we're sitting around, um, just chewing the fat, talking astronomy for a while. So get away from the TV for a while, get away from the news, and have have sort of an interesting, exciting conversation about astronomy amongst a group of friends. So tonight's drink of choice is yet again hydrogen hydroxide. It's yeah, it's a little more mellow than dihydrogen oxide. So I sort of prefer uh, the more mellower hydrogen hydroxide as my drink of choice. So cheers. So for those of you who are listening to this in the future, make sure to like this video. Make sure to just to subscribe to this channel if you haven't already, and definitely hit that share button and spread the word about this new live stream that I'm trying to get some traction on. I hope it's interesting. I think with a larger crowd, that'll change the energy a little bit and make it even more interesting and exciting. Um, but yeah, I'm just gonna keep going as I am. And so, hey, let's get into it a little bit. So tonight, I thought that I would share some data that I just collected maybe half an hour ago or so. Um, there was a very nice pass of the International Space Station over my location. And so what I'm going to do is I'm just going to show that off to you. I'll start at the beginning. I'll get it loaded up here, and then I'll share the screen. Okay, that's not it. That's not it. That's not it. Here we go. Getting there. We're getting there. Getting there. Okay, here we go. So let me share the screen. Well, don't hit stop broadcast. What we want to do is we want to share the screen. And we're going to go to infinity here. And then I'm going to go here. And so what I'm looking at is, as I said, these were just taken maybe half an hour ago or so. Here's a overexposed image of the moon. You can see all the rays coming off of that, all the little optical effects that happen when you have something really bright in your field of view. And I do have this guy rotated by about 90 degrees. So that's why it looks like it's getting brighter over here, because this is actually the horizon over here. But if you look really carefully, right there, you might see a little streak. And I guess what I can do is I can at least attempt to zoom in a little bit, and we'll scooch this over there. Whoop, didn't scoot it quite far enough. Got to do this one-handed, so I got to hold the mic at the same time. So way over here, you can see there's a little, looks like a little white line, and that actually is the space station. So I took 4-second exposures, and so because this particular bright object is moving in the sky, it's going to look like a streak like that, a little line moving along. So let's see. Okay, here we go. So it's keeping the same zoom. I'm just going to sort of scan through or move through these images, and you'll see that it is moving. So these are 4-second exposures taken, almost as fast as I can take them. I do have to do this manually, so it's sort of a little bit of a pain to do this. I don't have anything automatic yet on this, but it was a very, very bright pass. This is about as bright as the International Space Station gets. Estimated magnitude is about negative 3.9. So in astronomy, the magnitude scale is sort of backwards from what you might think. So the larger the number, the fainter the object. So uh, uh, Venus is about -4, the Moon is about -12, the Sun is about -26. Vega, the star Vega, is sort of it is the standard 0 magnitude star. And then every change in magnitude. So the difference between a first magnitude star and a second magnitude star is 2.5. So a first magnitude star is 2.5 times brighter than a second magnitude star, and a second magnitude star is 2.5 times brighter than a third magnitude star, et cetera, et cetera, et cetera. So you can also see some background stars here, and I'm actually going to be able to do some relative photometry on the ISS to actually measure the brightness of the ISS and see, how well it compares to what the estimates are. I'll have to figure out exactly what stars those are, but that's not a big deal. So I'm going to keep going here, scan through here. Let me zoom out a little bit. It's going to be getting, it's going to be getting a little bigger. Got to push the right buttons though. Let me just grab this and like that. So as you can see, it sort of got pretty close to the moon. And you can see that, when as it's getting closer and closer to my location, its apparent motion, its apparent velocity is going faster and faster and faster. So I'll be able to measure that apparent velocity because I know that this is a 4-second exposure. So, this is when the exposure started, this is when the exposure stopped, and that whole interval there is 4 seconds. So then it went out of the field, so I sort of rotated myself around and caught it as it was moving away. So here you can see part of the constellation here. Here's the constellation Riga. This star here is Capella. And hey, look, it looks like there's another moving object in there, which I didn't see before. Look at that. So there's another, it looks like another satellite, a fainter one. So I'm going to have to go over to Heavens Above and figure out what satellite that is. So yeah, I didn't even notice this until just this moment, that here's the International Space Station and here's another satellite, fainter and moving a little slower, right? Because this is a 4-second exposure, but this streak is a little bit longer than this streak, which means that the ISS is moving a little faster than this, which probably means that this guy's further away. So I may be able to figure out, based on if I sort of know how far away this guy is, I'll be able to figure out also how far away that guy is. So that's pretty cool. That's pretty cool. Um, moving in different directions too. You can see that, because I've rotated this around, the ISS is now going to be moving to the left, and the streak is going to be getting shorter and shorter because it's moving away. And there's our other satellite there. Um, it's moving to the right, so it's actually getting closer and closer and closer. So that streak is getting longer, and that's pretty cool. Now, I guess what I want to do, because I'm here and we're live, and I had no idea that this other satellite was going to be in there, I sort of want to zoom in on that satellite a little bit and see if there's anything else interesting about it that I can see. It sort of looks like everything's a little bit out of focus. It's really, really hard, even in manual mode, to focus on these things. I set the focus um, to infinity, but it sort of looks like I still have some pretty nasty focusing problems. So I'm going to have to work on that a little bit, figure that out. All right, I'm going to zoom back out here if I can. Yeah. Okay, so let's watch the rest of the sequence. So there goes the ISS to the left, and the unknown satellite moving sort of to the right and down. And as you can see, if I back up a little bit here, if you watch the ISS, it's slowly getting fainter and fainter and fainter. Whoop. These buttons on my mouse pad here are pretty touchy. See, so there it's starting to get fainter. And the reason why it's getting fainter is because it's moving into the shadow of the Earth. So actually, after that exposure there, I think there's a little hint of it here, but the ISS has actually moved into the shadow of the Earth. And this guy's getting really, really faint. He's moving out of the field too. So I think that's the end of that sequence. So is that cool or what? Oh, here, just for your amusement, this is a little bit of my artwork, just to give a preview, maybe. This artwork is created with some software that I've written to allow me to draw, because I cannot draw for shit. So, but I I can write code to draw. So this this is what I call data art. This is actually using the orbital data from Jupiter's four Galilean moons, Io, Europa, Ganymede, and Callisto. And I take that orbital data, and I make pictures like that. So, but that's I'm not gonna talk too much about that now. Let's just I'm gonna go through this sequence of ISS images again. Uh, and I'm just gonna go backwards this time. It's really, really cool that there was another satellite in there. That's it's always nice to get a little surprise. Okay, so then this is flip back to the other side of the sky. So you get a big long streak of the ISS, and then it slowly goes down to the horizon. So I hope you like seeing that. I like doing this kind of stuff. What I'll do is I'll make a couple of videos showing this sequence, and I'll post those up on my channel as well. So yeah, I sort of hope you like that. Kind of fun to do that kind of thing. I'm gonna pop back in here. Doink. and get some water. I'm going to quickly check my audio here, so I'm going to put the mic down for a sec. I think it sounds great. It's a little softer than what I want, but I'll work on that. No worries. No worries at all. So yeah, I hope you like that a little bit. Um, I guess the other thing that I can talk about is this project slash collaboration that I am setting up with a number of folks online. I I'm a member of a number of Facebook groups. Um, about a project. What I'll sort of going to, because it's the more and more I think about it, the more complicated it gets, and I for one really enjoy that. So I'm going to share my screen again, and I'm going to try something new. I'm going to try to draw on the screen just using Paint. Just Microsoft Paint. So we go to Infinity, and then I'm going to go over to Paint like that. And I'm going to check my size, make sure that I've got a nice big thing. So this is going to be incredibly challenging because as I mean with so drawing on a laptop is going to be even more fun. It's going to be even more fun. But I'm certainly going to try, and this is part of the process of learning, and sometimes it's interesting to observe others learn. You sort of get a sense, maybe of your relative position to that, and hey, if you have any suggestions um, in terms of being able to improve upon this, please let me know. Now I could have prepared some and all that, but this is a start. I have all prepared. People are doing these kinds of things on the fly. So what I want to describe um, to ask is that you hang with me. Okay, hang with me. If it looks some pretty cool, almost science. I wouldn't necessarily call this science, but this is pretty close to the full scientific process. There's a couple of steps that are left out of the scientific process here, but yeah. So I'm just gonna get going. So let's just say what this whole method of measuring the distance to the moon is based on this concept of parallax. And in fact, what I'm going to do really, really quick is I'm gonna throw myself back on the screen here, sort of show you uh, what I'm talking about first. Now, the idea of parallax, you can actually see for yourself um, right where you're sitting. Um, Maybe you've done this a bunch of different times and not really realized what was going on with that. So if you put your finger out, maybe at arm's length, and just put your finger up like that. Here, I'll sort of do that, and then close one eye and look at your finger, and then if you blink your eyes back and forth like that, and really what you need to do is you need to look at like a distant object. You can't have something up close. I was trying to do it up against my laptop screen, and I wasn't really seeing an effect. Okay, but if you sort of point your finger up at arm's length, and then put it against a background that is relatively far away, right? I mean, I can look across the room here, which is probably um, 10 feet away, and I'm seeing a pretty good effect. And what you want to do is just, close one eye and look at things, and then open that eye and close the other. And what you'll see is that your finger seems to jump back and forth, back and forth, back and forth, back and forth, like that. Okay? So that's sort of part one of this whole thing. So now I'm going to share my screen, and I'm going to try to draw. So we're going to infinity, and I'm going to hide this, and we're going to go back to this. This is just Windows Paint, right? So just bear with me, okay? So let's extend this a little bit. I'm going to draw, hopefully, a pretty crude circle. That's incredibly crude. Okay. This is supposed to be the Earth. Okay. It's a pretty bad circle. I wonder if I should probably experiment with these kinds of things offline. Let me see if I can make a slightly better circle. That's slightly better. Yeah. So now how do I move that around? Oh, I can move it around like this. Little arrow keys. Yeah, this will be a little better. And my apologies for maybe the sound going in and out. I'm sort of a cheapskate, and I don't have a microphone stand yet, so sometimes it moves away. Okay, so now I'm going to go to pencil drawing mode. So consider this the surface of the Earth, okay? And what I'm also going to do is I'm going to draw out here. I will draw a little moon, okay? Something like that. Something like that. So So now let's pick two places on the Earth. Maybe I'll change color for this. Change color. So let's pick a spot. You know, everybody on the left side of the Earth, everybody over here is obviously not going to be able to see the moon, right? Because the Earth is blocking it. You'd have to look through the Earth in order to see the moon. But everybody on this side of the Earth, it does see the moon, and it's in some place in the sky. Okay, if you're over here on the Earth and looking at the moon, depending on how the Earth is rotating, and I'm not going to get into that here, the moon's either going to be rising or setting, and the same thing over here. If you're standing right here on the Earth, the moon would look directly overhead, or at least on the north-south line. Um, so let's just say that somebody's observing the moon right there, and somebody else is observing the moon right there. I think I can draw lines. I'm going to do that. So from this point of view, I'm going to extend this line out a little bit for a reason. From this point of view, the moon is that away. Okay? And from this point of view, the moon is that away. So if you're looking at the moon with the stars in the background, the position of the moon, according to this observer on the Earth, is going to have a certain star pattern in the background. And from this position on the Earth, the star pattern is going to be slightly different, right? Because you're looking at a different portion of the sky. Hopefully that makes sense. Yeah, Tom, I'm talking parallax, just sort of getting into explaining a little bit more. No audio? Absolutely no audio at all. Okay, so let me stop sharing. And I will say, hold on 1 minute, working on it. So let's see what's going on here. Oh, there we go. Are we back? I think we're back. Looks like we're back. Okay, so I'm going to share again. And I guess I'll just keep my headphones on myself so I don't. Okay, so I'm going to hide that again. I'm going to go back to this. Whoop, I'm going to go back to this. All right, cool. Yeah, sorry about that. I don't know what happened. Technical problems. Oh, I'm going to draw that. Draw a line. I love these live shows, you know? Oh, damn it. Okay, so now I'm going to go to that, and I'm going to do this. Click on that, and I'm going to go blue. Oh, okay. So I location of this observer, and I know the location of that observer, so I can calculate this distance. Oh, now I've got a kitty on the lap. I've got to reconfigure. All right, this is not going to work, kitty kitty. There we go. So yeah, I can calculate the distance. And I'm going to be able to measure this angle. And if you know a little bit of trigonometry, okay, I think the sound is okay, so I'm going to get the headphones off because it's hard to listen to myself with the delay. So Tom, just let me know if it goes out again. I appreciate your backing me up here a little bit. Okay, so hopefully I'm still on. Just took the headphones off of my ears. So if you know a little bit of trig, you know that if you know one side and one angle, you can calculate everything else. Because ultimately, what I want to be able to measure is either sort of the distance between the center of the Earth and the moon, or the distance between the observer and the moon, and this observer and the moon. And that's really all that's to it. It's about as easy as that. So yeah, I'm pretty excited about this. I think it's going to work out really, really well. And really, the only requirement is that the images are taken at pretty much exactly the same time. And I've got to have a bright star or a bright planet somewhere in the background that the camera is going to be able to see, because then I will be able to measure the position of the moon relative to that background star for both of the locations. And I know that the background star position uh, hasn't changed because it's too far away. But the moon is close enough to see this slight little shift. And so I'm just going to measure that angle, and I'm going to know this distance, because I'm going to know at least approximately, uh, as closely as participants are going to want, to provide information about their locations. I'll be able to know with some pretty good accuracy um, uh, how far away these guys are. The only real trick here um, is that measuring the distance on a sphere, okay, um, is actually going to be along this, right? I mean, if I just took the location here, like the latitude and longitude here, and the latitude and longitude here, and calculated, the distance, I would actually get this. So that's not quite right. I want this distance instead. So I'll have to calculate that out. That's easy enough to do. But as soon as that's done, everything else is going to fall out really, really easily. Because then it's all you have to do. Let me go back here, this, and let's see. Let's pick a nice green, um, and I want to do a line. So that's sort of the rest of the triangle, right? So this is now a right triangle, and this is a right triangle, and I'm going to know this distance here because it's just going to be halfway, right? And I'm going to know that angle, this little small angle here, is just half of the big angle. And so since I know this distance and I know that angle, I can calculate everything else. So I can calculate this red line that goes from the observer to the moon, and likewise with this red line going to the moon, and that is the distance to the moon. So pretty cool and really, really easy. And what I want to do is make multiple measurements, not only uh, on the same day and time, but at different days and times. And the only requirement, for a data point uh, is that the images are collected pretty much at the same time. Plus or minus 10 minutes, something like that. It doesn't have to be incredibly exact. The more exact it is, the more precise the measurement will be. But I'm not going to sweat, you know, um, you know, requiring that everyone, you know, take this image at exactly, 3 hours UTC. So the other um, uh, both interesting thing and sort of a bummer about this is that not everybody is going to be able to participate at the same time. As I said at the beginning, okay, if you're on this side of the planet, then you're not going to be able to see the moon at this time. So you're just not going to be able to take a picture of it. Only the people who are going to be able to see it are going to obviously, be able to photograph it. So hopefully my audio is still good. Let me check that. I guess really, really quick. Yeah, it looks like the audio is still going. Good, 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 good. So hopefully that makes a little bit of sense. Tom, are you into math at all? Much? I am heavy into math. I've gone all the way with math. So uh, yeah, trigonometry is absolutely no problem for me, and I'm the one that's going to be coordinating this collaboration. So I will once I have sort of a decent list of participants, and I already have probably like half a dozen or so, which is adequate. That's more than enough. The more participants we have, the more data we have, and the more both accurate and precise will be with these measurements. And one of the really, really cool things is that the the moon doesn't orbit the Earth in a perfect circle, right? It's an ellipse. So every measurement of the distance is going to be slightly different, and so I can actually compare uh, our measurements to the calculated distances, and see how well that compares. That's a measure of accuracy. And then if the measurements are consistent, then here we go. Um, if the measurements are consistent, uh, then that's that is going to give us a good sense of our precision. So yeah, I think this is going to be really, really fun. It's a project that I've wanted to do for a long time, and it um, in terms of participation from you, it's super, super easy. You just have to take a picture of the moon. You don't, I mean, you don't even have to um, line things up. I mean, you just have to aim and shoot. Um, as long as I can see the moon and this bright star or planet um, in the field of view, um, I'll be able to do this calculation, no problem. So I think that's going to be really, really fun and cool. And hey, Tom, I think uh, you came in after I showed the images of the space station um, um, that I took just prior to uh, to the stream here. So go back and take a look at that. I'm going to make probably a couple little movies and post them on this channel as well. So you'll be able to see those. Got a little bit of a surprise, which I didn't see until I was looking at it live on here. There was another satellite at the same time going over. So I not only got the International Space Station going over, I also got another satellite, and I'm going to have to check with Heavens Above to find out which satellite that is. And under a little bit of um, close examination, I sort of noticed that the images are out of focus and don't look all that great, but it's something, and it's pretty neat, I thought. So all right, I'm going to unhide myself, stop sharing. That is, get back to this big ugly mug. And so hopefully everything is going okay for you today, Tom. I like the idea of a daily show, but, because we can sort of check in every single day. This is a circle of friends, and you may have noticed, hopefully, that at least when it's working, the quality of the audio is up a little bit, and that's because I dug out this microphone here. Unfortunately, I don't have a microphone stand yet. So I'm having to hold it, and so I'm moving it around, and that's probably pretty distracting. This is a continuous work in process, just like science itself. So um, the output from this is going to feed back to the input of this, and hopefully the process is one of pretty much constant improvement. So cheers. Hello. All right, hold on. Working on it. Working on it. Yep, there it is. Okay. Yeah, it's one of the connections on the mic. So, yeah, that's how it goes. But the cool thing about live is that I can just try again tomorrow and make it better, hopefully tomorrow. Um, this is a mic that I've had for a while, and it's really, I mean, I'm going to show the world, the clunkiness of this mic. So it goes from uh, oh, I forget the three prong thing up here to a single quarter inch here, and then down to an eighth inch here, which goes into my microphone jack on the laptop. All right, cool. Thanks for stopping in, Tom. Glad you could stop by. Definitely, make sure to share this, spread the word for sure. Thinking about what I can do, to draw in a little bit more. Trying to be relatively active in terms of, marketing this. Um, so yeah, very, very cool that you could stop in. And as I said, those of you who are viewing this in the future, glad you could stop by. Um, yeah, this is a daily thing, very, very casual. Definitely with more of a crowd, it'll be a little bit more fun. So part of my job is to bring in more folks. Would definitely like some panelists on here. Um, Email me if you want to be the on the live panel. It'll be right there. And just all line up along the bottom, and we can have a even more of a live conversation. But I think it's now 3:07 UTC, so I'm going for a little bit over an hour. Hopefully, it was moderately informative and interesting. And yeah, I think I'm going to exit this planet, get back up to the spacecraft, and yeah, I think for now it is going to be peace out, and I will see you again in about 23 hours. All right, take care, and yep, see you tomorrow. Astronomy Daily Live every single day, 2 hours UTC. Peace out.